Jai Hind, dear students. I'm Dr. Preeti, and today we are going to start with the chapter Metals and Non-Metals. In this chapter, you will be having one question as an MCQ, one question as filling the blanks, both for 1 marks each. One question as a very short answer type question, that is again for 1 marks, and one question for 2 marks. Okay, so this is the mark distribution. In this chapter, we are going to see about the physical and chemical properties of metals and non-metals. Then we will also see about the extraction of metals, but that will be in the next video. So here we start with the physical properties of metals and non-metals. Especially based on the physical properties of metals and non-metals, you could be having a 1 marks question in your exam. So we need to remember the physical properties, especially the exceptions or the things which are different from the rest. So that is very important. Metals, as you know, that they are usually lustrous, they have a shine, they are sonorous. That is why they are used to make bells. They are hard, they are solid. They are usually having a high melting point, high boiling point. This is the general characteristic feature of metals. And non-metals are usually opposite to all that. So, but let's see that one by one. Metals are usually having a great luster, a shine. They are usually solid. But now what is important is the only liquid non-metal is mercury. That is the only liquid non-metal. And cesium and gallium are very important because they are solid at room temperature. But if you just hold them in your palm, then they will turn liquid. So cesium and gallium will be turning liquid at a slightly higher temperature than room temperature. Just in your palm, they will become liquid. Then they are malleable, means that they can be drawn into thin sheets. That is why we are making aluminium foil, silver foils are available, and especially gold and silver are the most malleable elements. सबसे ज़्यादा thin sheets we can prepare from gold and silver. They are very good conductors. Best conductor is silver. Second number is copper. That is why we make wires out of copper. Okay, why don't we use silver? Silver is the best one, but we don't use silver because it's very expensive. So second option after silver is copper. So we use copper. Then poor conductors, again an important thing to remember. Which metals are not good conductors or poor conductors of electricity? So that is lead and mercury. Lead and mercury are poor conductors of electricity. Then they are sonorous also. That is why they are used to make bells. है ना, घंटियां बनाने में use करते हैं हमको. They produce some sound, so they are sonorous. They are usually hard, but the exceptions are very important. Just remember that very well. Lithium, sodium, and potassium. These three metals are usually soft, and they are so soft that they could be easily cut with a knife. Just imagine you are cutting a metal. Can you even imagine cutting iron with knife? No. But lithium, sodium, and potassium are so soft that they could be cut with a knife. And whenever you put any metal into water, that usually sink in water because they have a high density. So usually metals have high density, but lithium, sodium, and potassium, they have density also very low. So they have low density also. Apart from that, their melting point is also low. If you try to melt them, you just try to heat them, then they will easily melt away. Okay, so सबसे low melting point इसका हुआ, that is mercury, liquid at room temperature. Then comes cesium and gallium, and then comes these lithium, sodium, and potassium. They also have low melting points. Now if we talk about non-metals, they are usually not having luster, but graphite is one that is having luster. Apart from that, iodine is also there, that is also having luster. That is the only non-metal that is lustrous. Apart from that, they are usually occurring in the gaseous state. For example, oxygen, nitrogen. So you see non-metals either as solids and usually as gases. But the only liquid non-metal is bromine. Okay, only liquid non-metal is bromine. Only liquid metal is mercury. Next is their oxides. If we talk about the oxides, their oxides are acidic in nature, and that of the metals are basic in nature. Oxides of metals are basic in nature. We are going to talk about it more. But oxides of non-metals are acidic in nature. You can remember that with one example: carbon dioxide, nitrogen oxides, sulfur oxides, they all lead to acid rain, you all know. So these are all non-metals, nitrogen, sulfur and carbon, and their oxides leads to acid rain. So that is how you can remember that non-metal oxides are acidic in nature. I'll just shift to side. You just take a screenshot of the same so that in one go you can remember that this thing covers almost the first 3 pages of your book. From metals and non-metals, whatever is given in the first 3 pages, that is all included in this thing. I hope you have taken a screenshot. Now we'll talk about the reactivity of metals and non-metals, and we are going to talk about how they react. Especially for metals, we will learn that how they react with oxygen, how they react with water, how they react with acids, and what will be the reaction of metals and non-metals, and the reaction of metals with other metal salts. All that we will study now. In your book, what they have given, they have shown the reactivity of different metals with different things, and based on that reactivity, we have concluded what is the reactivity series. But we are going to progress in a opposite way. First, we'll learn the reactivity series, and based on the reactivity series, we'll see the properties. Then it will be easier for us to remember those properties. Okay. So just first, let's see the reactivity series. This reactivity series tells us which metal is more reactive and which is less reactive. I'll also tell you how you can remember this reactivity series. I'll be writing it down. Karan ne कार मांगी, ऑल्टो, जेन, फरारी, पापा बोले हंगामा क्यों होगी आगे और पिटाई. Okay, you can remember it. करण ने कार मांगी, ऑल्टो, जेन, फरारी, पापा बोले हंगामा क्यों होगी आगे और पिटाई. This is the reactivity series. This shows that sodium and potassium is the most reactive. Then comes sodium, calcium, magnesium, aluminium, zinc, iron, lead. This is hydrogen, a non-metal that is included in this reactivity series. I'll tell you why it is included here. Then it's copper, mercury, silver, gold and platinum. Okay. So based on this reactivity series, we will study about all the properties of metals, the chemical properties now. Okay. So first we'll see the reaction with oxygen or reaction with air. The first property of metals that we are going to see, that how metals reacts with air or how they react with oxygen. It's the same. Sodium and potassium, you can see they are highly reactive. So they are so reactive that even if you put them in air, they are going to catch fire. They are going to burn very easily. So to store them, we store them in kerosene oil. Okay, if you just put them in air, they are going to catch fire. So we store it in kerosene oil. Next, calcium and magnesium are also very reactive, but not as reactive as sodium and potassium. When metals reacts with oxygen, they produce oxides, metal oxides. So let's see some examples. For example, when sodium reacts with oxygen, it forms sodium oxide. And these metal oxides are usually basic in nature. So they are, we have seen earlier na, that non-metal oxides are acidic and these are basic in nature. So when they are going to, since they are basic in nature, they can react with any acid to produce salt and water. So this is about sodium oxide. Similarly, calcium and magnesium also, they will react with oxygen to form metal oxides like calcium oxide, and magnesium is going to form magnesium oxide. We have seen earlier that magnesium ribbon, if we take and we burn it in air, that produces a dazzling white flame. You can be asked, what is the color of the flame when magnesium ribbon is burnt? So when magnesium ribbon is burned, it produces a dazzling white flame. But if you remember, we have done an activity that when magnesium ribbon has to be burnt in air, then first it needs to be cleaned. Why? Because these metals like magnesium, aluminium, zinc, they are so reactive. Then when they come in contact with air, they form a layer of oxide over it. And that is also a protective layer of oxide. It doesn't prevent the further metal to react with anything. So magnesium forms a layer of magnesium oxide over it. And so if you want to burn a magnesium ribbon, first you need to clean it with sandpaper and then only you can burn it. Otherwise, the layer of magnesium oxide present over it doesn't allow it to react with everything. Okay, so that is there. So all these metal oxides are going to react with oxygen to produce metal oxides, but all the metals do not react. For example, we have seen sodium and potassium, they are going to react very vigorously, very quickly. Even when exposed to air, they are going to just catch fire. Then if we come to lower metals like magnesium, we need to provide heat, we need to burn it, and then only it is going to catch fire. If we talk about iron, iron is not going to if we bring a metal strip of iron and if we try to put it on flame, it is not going to catch fire. But remember, iron fillings means iron ka chura bilkul. So if we put iron fillings over flame, then that is going to catch fire. That is going to burn vigorously. It's going to catch fire. If we talk about copper, copper also reacts with oxygen, but it will not catch fire. It will just form copper oxide, that is going to form a black layer of copper oxide. Okay, CuO is formed and that is a blackish layer of copper oxide. So these metals are going to react with oxygen. But metals like mercury, silver, gold, these are not going to react with oxygen. Okay, so the more reactive elements are going to react, the very highly reactive metals are going to catch fire. The other metals like iron is not going to catch fire in its strip form. Similarly, copper also will not catch fire, but it will form a black layer of copper oxide. Now, these metal oxides are usually basic in nature, I told you, but some metal oxides are there which are having amphoteric nature. Okay, aluminium especially, it's given in your book. So aluminium has amphoteric oxide. Amphoteric word का meaning क्या होता है? Ampho word means dual nature. For example, we have seen amphibians in class 9. So amphibians are those organisms which can live in both water as well as land. Amphi word means both, है ना, dual nature. Similarly, here their oxides are known as amphoteric oxides because they have the dual nature. Means since they are basic in nature, they will react with acid to form aluminium chloride, that is salt and water. But since they are also having acidic nature also, so they are going to react with base also. When they are reacting with base, that shows that they itself have an acidic nature. They are reacting with acid, that shows that they have a basic nature. So these are amphoteric, showing both acidic as well as basic nature. So they react with the base to form ठीक है. So that is going to react with base to form salt, and again water will be formed. So aluminium oxide is amphoteric oxide that is going to react with acid as well as base. Fine. Now I told you that a protective layer of oxides is formed over the metals, and that doesn't allow the metal to react further with anything. This property of metals is used in a process known as anodizing. Anodizing, as the word says, it's something related to anode. So what is done? It is specially used for aluminium articles. So we use vessels in the kitchen that are made up of aluminium. But aluminium is a metal, so that can react with acids or something. But we want to prepare the utensils out of it because it's a very good conductor of heat and it's lightweight also. So we want to prepare utensils of that, but that shouldn't react with the acid content of our food. So what we do is we just want a very thick layer of aluminium oxide over our aluminium utensil. For that purpose, we perform anodizing. In anodizing, what is there? That we take sulfuric acid as an electrolyte and we connect one of the terminals to the positive terminal and the other terminal to the negative terminal of the battery. At the positive terminal, that is anode, we keep our aluminium article that needs to be that we need to make it a thick layer of aluminum oxide. When we pass current through it, what will happen? Oxygen will be formed and oxygen will come over anode because anode is positively charged and oxygen is negatively charged. So it will be attracted towards anode and this aluminium present at the anode will react with this oxygen and we'll get a thick layer of aluminium oxide. And this aluminum oxide will prevent the further corrosion of aluminium article. Okay, if we just keep it in a exposed to environment, then a thin layer of aluminum oxide will be formed. But by this anodizing process, we can get a thick layer of aluminum oxide. That is why we perform the process of anodizing. So that is how different metals are going to react with air. Now we will see the reaction with water. Some metals like sodium and potassium, they are so reactive that even if they they are put in water, they are going to catch fire there also. You know, that is why we put them in kerosene oil and not in water. Because if we put them in water, they are going to react with water and they are going to catch fire. Why they are going to catch fire? Let's see that. So when these metals, when they react with water, first they form their oxides. And these oxides again react with water to form hydroxide. When this oxide will be formed, hydrogen gas will be released. So then when they further react with water, they are going to form their hydroxides. But what will happen? This hydrogen gas will be formed and this reaction is so exothermic that such a lot of energy is produced that this hydrogen will immediately catch fire. So sodium and potassium both, when we put them in water, they are going to catch fire very easily. So that is there with them, okay, because of the form. And what will be formed from these metals? Their hydroxide is produced. They are going to react even with cold water, okay. Calcium also reacts with cold water, but the reaction is not so vigorous. So what will happen if we put a calcium in cold water? Then bubbles of hydrogen will be formed and that will stick around it. So this calcium is going to float on water. So you could be asked in the exam that which metal will float on water, on cold water. So that is calcium. Okay. The sodium, potassium, calcium, these three react with cold water. Calcium floats and sodium and potassium catches fire even in cold water. So next is magnesium. Magnesium is not going to react with cold water. If you put magnesium in cold water, it's not going to react, but it is going to react with hot water. Again, with hot water, hydrogen bubbles will be formed that will be just encircling the magnesium, and the magnesium will also start floating on water. Okay, so that is how these metals are going to react. These metals like sodium, potassium, calcium and magnesium, when they react with water, they are going to produce their hydroxides. Okay. But if we see about the next three metals like aluminium, zinc and iron, they are not going to react with cold water, not going to react with hot water also. Then they are going to react with steam. They will be reacting with steam. So if we make iron to react with steam, Here you need to write either G, that is showing the gaseous form, or you can write steam. Then their hydroxide will not be formed. In case of sodium, potassium, calcium and magnesium, hydroxides were formed. But in case of aluminium, zinc and iron, their oxides will be formed. Here Fe2O3 will be formed and hydrogen gas will be liberated out. Hydrogen gas will be formed. Similarly, aluminium also, aluminium when reacts with steam, it will form aluminium oxide and hydrogen gas will be liberated out. So that is how these metals are going to react with water. Lead, copper, mercury, silver, gold, platinum, they will not be reacting with water at all. Okay. So remember, sodium, potassium, calcium, magnesium reacts with water. Sodium and potassium catches fire in cold water. Calcium starts floating on cold water. Magnesium starts floating on hot water. Aluminium, zinc and iron reacts with steam, but rest of the metals are not going to show any reaction with any temperatured water. Okay, not steam, not cold, not hot. Okay, now we'll see the reaction of metals with acid. Reaction of metals with acids. Now, when metals reacts with acids, one example we can take, for example, aluminium. So, when it reacts with any acid, what we will form is hydrogen gas will be liberated out. Okay, if we take a test tube in which we put some zinc granules or aluminium granules and we put some dilute sulfuric acid or dilute HCl, then what will be formed? That will be reacting with that acid salt will be formed and hydrogen gas will be liberated out. How we can check that hydrogen gas is liberated out? We will connect a delivery tube to it and we will pass it through a water bath. Now, when the bubbles of this hydrogen gas will be coming out through the, we will put some soap solution in that. When the molecules of hydrogen will be coming, passing through that soap solution, they will be trapped in that and will bring a burning candle that will burn off with a pop sound. That will show that hydrogen gas is liberated. So, when metals reacts with acids, they produce salt and they produce hydrogen gas. Hydrogen gas is liberated out. But this reaction is shown till aluminium will be reacting with acids, zinc will be reacting, iron will be reacting, but copper cannot react with acid. It is not going to react with dilute HCl and it will not be releasing hydrogen gas. Why is it so? Because you can see for this reason only we have placed hydrogen also in our periodic in our reactivity series. Copper being less reactive than hydrogen, how it can displace hydrogen. Okay, here we have seen that aluminium is displacing hydrogen because aluminium is more reactive than hydrogen according to the reactivity series. So it will just remove hydrogen from acid and it will take its place. Okay, but copper cannot react with acid because it is less reactive than hydrogen. Okay, so metals usually with acids they react and produce hydrogen gas, but one acid is there when it reacts with any metal it doesn't forms hydrogen gas, instead it forms water. Okay, try to recall the name of that acid. I'll be writing it on the board. Just think. I hope you have guessed it correct. You have recalled it. That is nitric acid, HNO3. So these metals, when they react with any acid, they produce hydrogen gas. But when they react with nitric acid, instead of producing hydrogen gas, they are going to produce water. And nitrogen oxides will be produced. Nitrogen oxides will be produced means it could be N2O, NO or NO2. Okay, these nitrogen oxides could be produced apart from water. Why water is produced? Why not hydrogen? Because nitric acid is a very good oxidizing agent. एजेंट मैंने बताया था that it will help others to get oxidized. So it's a very good oxidizing agent. तो वो हाइड्रोजन जो लिबरेट हुआ उसका ऑक्सीडेशन कर देता है. And so instead of hydrogen gas, water is formed. Okay. So this is the only acid which when reacts with metals in a very dilute stage, in a dilute form, then they are not going, the metals are going to produce water and they are not going to produce the hydrogen gas. But still one more important thing is there, manganese and magnesium. These are the only two metals which when reacts with very dilute nitric acid, they are going to produce hydrogen gas instead of water. When manganese and magnesium reacts with very dilute form of nitric acid, only very dilute. If they are going to react with concentrated, they will also produce water and nitrogen oxides only. But when they react with very dilute nitric acid, they are going to form hydrogen. Okay, so since it's an exception, it becomes important for you all. So this is the reaction of metals with acids. Next is how the metals reacts with the other metal salts, with the salts of other metals. So in this we have the displacement reaction. For example, if iron reacts with copper sulfate, it will give ferrous sulfate and copper will be displaced because iron is more reactive than copper, so it will displace copper from its salt solution. Okay, how we will come to know about it? Copper sulfate is a blue colored solution. Okay, so if we put iron nail in that and after some time we will see that the blue color has disappeared, it turns somewhat greenish because ferrous sulfate is a greenish solution. So this is the example of displacement reaction. Any metal that will react with another metal, that is that metal, if that metal is more reactive, it will displace another metal from its solution. Based on the reactivity series, you can work out which metals are going to displace another metal. Okay, so that is how metals reacts with other metal salts. Next is reaction of metals with non-metals. What happens when metals reacts with non-metals? For example, what will happen when sodium will react with chlorine, magnesium will react with chlorine, or sodium is going to react with oxygen. So that is a reaction of metals with non-metals. Metals are ready to give the electrons. For example, sodium, it has one electron in the outermost shell. It tries to give that electron. If we talk about chlorine, so chlorine has 7 electrons in its outermost shell. It wants one more electron to complete its octet. So the metal and non-metal are going to react with each other and form a salt like NaCl. Okay. Such compounds which are formed by reaction of metal and a non-metal are known as ionic compounds. So we'll see the properties of ionic compounds also. We'll see some formation of some metals. How this question will come in your exam is, show the electron dot structure of magnesium chloride, sodium oxide. So these are all the electron dot structures which we are working out. Or we can say show the formation of magnesium chloride by transfer of electrons. Then also the answer is the same only. So what happens, suppose magnesium reacts with chlorine. So you know that magnesium atomic number is 12. It has the configuration 282. It has 2 electrons in its outermost shell. So it wants to lose these 2 electrons. So it will react with chlorine, that is having 7 electrons of itself. So magnesium will be giving one electron of its to 2 other chlorine atoms, and what will be formed? Magnesium will get converted to +2 charge. Why +2? Because it has removed 2 electrons. Okay, so earlier it was having 12 protons which are positively charged, and now when it has given 2 electrons, so earlier it was having 12 electrons also, but now it is having just 10 electrons. So it will be having a +2 charge. Mg +2. Since it has given 2 electrons, it will gain positivity. It will become +2. And chlorine, it was already having 7 electrons of itself, and it has taken 1 electron from magnesium. But how many charges there? -1 on 1 chlorine atom. And total how many chlorine atoms are there? 2. So it will form magnesium chloride by this way. Similarly, you can draw the electron dot structures or the formation of magnesium chloride or sodium oxide or magnesium oxide in a similar way. Okay. So that is how the metals reacts with non-metals and form ionic compounds. These ionic compounds, the properties of ionic compounds could be asked, but this is very easy to remember. When you want to remember the properties of ionic compounds, just think about salt. So how is it? Salt is solid, है ना? Namak, it's solid. So the ionic compounds are usually solid. Now think, actually, you must have seen in trucks the people sell salt as big rocks. So actually, salt occurs as big rocks because that is hard, that is having a hard crystalline structure. So ionic compounds are usually hard, and they are having a very strong intermolecular force of attraction between one NaCl molecule and the another NaCl molecule. They have a very good force of attraction because here it's positive, here it's negative. So it will all not only be attracting the Cl that is next to it, but also the Cl that is from the another molecule. So they have a very strong intermolecule. This is one molecule, this is second molecule, and they have a very strong force of attraction between the two molecules also. So that is why they are hard and solid. Apart from that, melting point and boiling point, that is also very high, है ना? If you try to take a salt in something in a vessel and try to heat it, how much you heat it, you will not be able to melt it because it's having a very high melting point. A boil तो फिर और भी बाद में होगा. So the boiling point is even higher. And they are usually solids. They have usually a high melting point. They conduct electricity in molten state as well as aqueous state. If we dissolve them in water, that will conduct electricity. If you just take them in molten state, मतलब heat करते करते उनको पिघला दोगे, then also they are going to conduct electricity. Okay. So that is the some properties of ionic compounds. हमने जो कार्बन के compounds पढ़े थे yesterday, that were all covalent compounds. So their property is different from ionic compounds. इसके opposite होती है. For example, carbon dioxide, you know, it's gaseous state. So covalent compounds usually don't have a very strong intermolecular force of attraction, and they usually occur in gaseous state क्योंकि एक molecule दूसरे molecule को attract ही नहीं कर रहा, तो पास पास नहीं रहेंगे, दूर जाएंगे एक दूसरे से, and that is why they usually occur in the gaseous state. Okay, the covalent compounds have usually a low melting and low boiling point. वही attraction ज़्यादा है तो melting point और boiling point भी ज़्यादा होगा. But when attraction between molecules is less, the melting point and boiling point will also be less. Just I have compared the properties of both ionic as well as covalent compounds. Okay, so that's all for this part of the chapter. In the next class, we'll see about the metallurgy, how we'll extract the metals from their ores. Okay, so have a nice day.